Hello everyone. In this session, we are going to look into cache and persist in Spark. We will understand what are the different approaches for doing the persist and what are the internals of the cache. So before moving into the working of the cache and persist, we need to understand what is the meaning of cache. So when you do the cache of any of the data frame, so like for example, you have created a data frame, you have read a file and did some transformation, and you have created a data frame, and you have done the cache. That means it is getting stored in the RAM. Now the question is, in which part of the RAM it gets stored? So in the screen you can see. So this is my executor memory. So this box is the representation of my executor memory or the executor container. So for example, I have a executor memory of 10 GB. If I have provided executor memory of 10 GB, then 10% of that it will be shared or it will be reserved for the reserved memory. So so it seems like it's a 10 GB, but the 10% of that will be used as a reserved memory. Inside this executor, so if we go into detail of this executor memory, we have other two options. The first is shared memory pool and the executor memory pool. So when we do the cache of the data frame, so data frame is just like it holds the data. It holds the data, and internally it's an RDD which holds the data. So that data will be stored in this storage memory pool. Fine. So this storage memory pool can also use the executor memory pool if executor memory pool is empty or there is a space into that. As per our understanding, so we'll say that cache will store the data frame or whatever thing we want to cache in Spark, that will go into the storage memory pool. So now we are clear that where that cache stores the data. So cache is an optimization technique. It's a Spark optimization technique where you can use a data frame to cache, and that will help the full application not to recalculate or not to uh, build the same data frame again and again. So I'll tell you what I mean by this. So for example, I am reading a file. So my df equal to read CSV file. Okay. Now I have another data frame which will do something on the top of it, or which will just read some other file. Read other CSV file. Now I did some transformation here, and then I have another data frame, so called df2, which will df1 dot join df2. Now again I did some transformation, and then I again did df3 equal to d1 or df2 dot join some other data frame, or we can tell df4, which was created somewhere in this transformation. Now I can, to optimize this, or the other way I can say, like if we have to do the action, if I did an action df3 dot so if I'm writing the command action command, so this df3, so Spark will first recalculate df2. In the df2 it will see df1 df2 other thing, so it's df and df1, so it will calculate your df1 and df2, means it will recreate it. Now every time you mention df in any of the transformation, any of the join, if I'm using df multiple times, for example here I'm using df again, this join, so multiple times if I'm using df, that means the Spark will again go into the df, and this RDD or this data frame will be calculated, or this data frame will be built every time. So every time this processing will be done. So if I do something like df dot cache, okay, so that means this data frame, the partition into this data frame, because the data holds or data lies inside the partition, so that partition will be stored in the storage memory pool. And whenever you are going to refer this data frame in any of the transformation in below application, so the Spark will not go into this data frame, meaning the DAG of this application, and recreate the data frame. It will just get the data frame from this cache. So the Spark don't need to recreate it every time. It can get the output of data frame or the data inside the DF from the cache, which is in the storage memory pool. So this is the need of the cache. So now or storage memory pool will have some limited memory. So data frame can be put inside that. For example, this has around 10 GB of memory and your partition is of 20 GB. So that 20 GB will not come inside this. So what will happen? Some of the data will be put into the storage memory pool, the RAM, and other data will go into the disk. So by default, it will go into memory and storage. Memory plus storage, or you can tell memory plus disk. So by default, when you do cache, it will go into the memory and plus disk, and cache has only one option, memory plus disk, then no other option. So this means your data will the Spark will try to put your data or data frame into the memory RAM, which is a storage memory pool. And if it doesn't get into it full data or all the partition, then for example you have 20 partition, 10 15 partition comes into the memory, and other 5 partition can go into the disk. Now in the memory, the data is deserialized. Data is not in a serialized way. Okay. But in the disk, the data will be in the serialized way. So what is the difference in both these two? So when a data is serialized, then it will use less volume or less storage. For example, you have 15 GB of data. So after serialization, the data will hold the space of around 12 GB or 10 GB. But in deserialized, the data will be of same volume, or if it is of 15 GB, it will occupy 15 GB. Now the disadvantage of serialized data is whenever you have to use this data, you have to again use some, or the Spark will use internal methods, internal logic to change serialized data into deserialized, and that will be CPU intensive. That will use the CPU. So in this case, so whenever we store the data into the disk, apart from the cache and other things, so reading the data out of the disk is always CPU intensive, because we have to again change, or you have to again change the data from serialized to the deserialized form, and then only you can use it. So this is about the cache. If we want more other memory options or the storage option, then we have persist. So persist is a special kind of cache in which the option of the storage is memory plus disk. So in persist we have multiple options. We'll see what all things are available in the persist. So what are different storage level available in the persist? The first is memory only. So you want to store your data frame or the partition only in the memory. So if it doesn't get into the memory, then it will not be persisted. So in that case, only memory is used. In the memory, it will be in the deserialized way. So the performance will be good in this way. Okay. The other is memory and disk. So in memory and disk, the same thing. It will be similar to what is done in the cache. So this parameter of the storage level parameter of the persist is same as what we do in a cache. Fine. We want to store the data only into the memory, but not in a deserialized fashion, in the serialized fashion. So what will the advantage of that? So it will occupy less space. It will like when you will use this data, it will be not very fast as compared to only memory parameter. It will be in this case, in the serialized way, the space will be used less, but the processing will be bit slower as compared to memory only, because the data is in a serialized way. So while using the data, you have to again change the serialized data into deserialized. The other is memory and disk serialized. So this is same as memory and disk in the cache. So I had mentioned by mistake that in memory and disk it is similar to the cache. No, but this is wrong. In memory and disk, what will happen? The data will be deserialized in both the fashion, and in memory and disk serialized, that means data will be serialized in the disk and will be deserialized in the memory, which is similar to the cache. So the other option is only disk. In only disk, there will be no memory involved. All the data will be stored in a serialized fashion in the disk. The other is memory only underscore 2. That means the data will be stored into this memory storage memory pool. Data will be in the deserialized fashion, but there will be a replication of two. For example, there is some complex logic which you have created, and that will be used in multiple ways. Like you have created a data frame which holds the very complex calculated or logical data, and that data frame is going to be used in multiple ways or in multiple transformation inside the application, and you don't want that data to be loose, or you don't want the Spark to use the DAG and again recreate the data. In that case, you can have two replication of that particular data. In all the other cases, you will have only one replication. In case you lose any the replication or that data in the persist or in the cache, so the Spark will go look into the DAG, that graph, and with the help of DAG, it will recreate the data. But in memory only two, you will have two replication. If one is lost or one is any sometime it gets corrupt or evicted, in that case Spark can use the other replication, other copy of the data. So this was all about cache and persist. We should know like where to use it, and we should know the internal about it. We should know the difference between serialization and deserialization, which is more optimized. In some of the cases, you want memory to have a less space stored inside the memory. In some cases, you have very large data. You don't want to put into memory, half into memory, half into disk. You can put in directly disk. If that data is not getting used multiple times or in the least amount of time, that you can put in a disk. This is all about cache and persist. If you have any doubt in this topic, please you can ping me or you can directly mail me.